Have you ever wondered how a website, like, remembers what's in your shopping cart, or how your school keeps track of who's in what class? Well, it all comes down to databases. And today, we're actually going to build one, a simple student database right from scratch using SQL. You're going to see just how powerful a few lines of code can really be.
You know, learning the theory behind SQL is a great start. It's important. You learn about commands like select and from and where, but let's be honest. The real aha moment, that point where it all just clicks, that comes when you stop reading and you actually start building something.
And that's exactly our mission today. We're going to build something tangible. We'll create a small but surprisingly powerful student database. And you'll get to see how all those commands you read about actually work together to manage and connect information just like they do in the real world. All right, first things first. Before we even think about writing a single line of code, we need a blueprint, right? Every solid structure starts with a good plan, and for our database, that plan means figuring out our core components.
So let's start with the biggest piece of the puzzle, the database itself. The easiest way to think about it is like a big digital cupboard where we're going to store all our related data. For this project, we're just going to call our cupboard school_DB. Nice and simple.
Okay, so if the database is the cupboard, then inside that cupboard, we need some drawers. In the world of SQL, these drawers are called tables. And each drawer is going to hold one specific type of information. So one for students, one for courses, you get the idea. This separation is actually the secret sauce to keeping our data super organized and efficient.
All right, blueprints ready. It's time to roll up our sleeves and start building. We're going to create the actual drawers for our database now by defining the structure of our three essential tables.
First up, the students table. Let's look at the command. We're creating three columns here. ID, which is an int, that just means integer, a whole number. Then name, which is a varchar. Think of that as a text field that can hold up to 50 characters. And finally, age, another integer. Now see how we've marked ID as the primary key? That's super important. Think of it like a unique student ID number that makes sure we can never, ever mix up two students, even if they happen to have the same name.
Okay, next we need a table for our subjects. This courses table follows pretty much the exact same pattern. We've got a unique primary key called ID, and then a varchar column for the course_name. See? Nice and simple. And now for maybe the most important table of them all, the enrollments table. So pay close attention to this one. This table doesn't store any names or course titles. It only stores numbers, a student ID and a course ID. And this is the brilliant part. This table acts like a bridge. It creates a relationship that links a specific student from our students table to a specific course in our courses table. This right here is the absolute heart of what makes a relational database work.
Okay, our structure is now in place. We've got three empty tables just sitting there ready and waiting. But, they're not very useful without any actual information in them, so let's go ahead and populate them with some sample data.
So, we use the insert into command to add new rows of data. And with these two lines of code, we're doing a couple of things. First, we're adding Ravi and Anita to our students table. Then, we're adding math and science into our courses table. See how we specify which columns to fill, and then we just provide the values that go into them? It's that straightforward.
And boom, here's the result. Our code created actual data. If you look on the left in the students table, you can see Ravi and Anita are in there, and they now have IDs 1 and 2. The database just assigned those automatically for us. And it's the same thing on the right. Math and science are now in our courses table, each with their own unique ID.
Okay, time for the final insertion. This is where we use that clever connector table we made. We're inserting a row that basically says, hey, the student with ID 1 is enrolled in the course with ID 1. Well, who's that? That's Ravi in math. Then we add another row that says, student ID 2 is in course ID 2, and that's Anita in science. We're building the links.
Okay, this is it. This is the moment we've been building towards. Right now, all our data is in the database, but it's kind of stuck in three separate tables. So now, for the magic trick, bringing it all together to answer a really simple question.
So here's the central problem we need to solve. How do we get a list that shows each student's name right next to the name of their course? To do that, we'd have to somehow look across all three of our tables at the same time. How in the world do we pull that off?
The answer is with the power of the join command. Let's just break this down real quick. We select the student's name and the course's name. We start from the student's table. Then, and this is the key part, we join it to our enrollments table, but only on the condition where the student's ID matches the student ID in the enrollments table. Then we do another join to the courses table, connecting them on the course ID. It's literally like building two bridges to link all our separate islands of data.
And there it is, the result. Our database followed our instructions perfectly. It walked across those bridges we built and gave us this beautiful, clean table. Now we can clearly see Ravi is taking math and Anita is in science. We've just transformed separate, raw pieces of data into actually useful, connected information. How cool is that?
So we just built a tiny little database for a school, and that's cool, but why does this simple exercise matter so much? What's the big picture here?
Because this exact pattern, separating data into different tables and then linking them together with IDs, it's the engine behind almost every single digital service you use every day. An e-commerce site, it joins customers to their orders. A hospital, it joins patients to their doctors. I mean, the fundamental principle you just practiced is what makes the entire digital world go round.
So where do you go from here? Well, first, let's just take a second to recap what you've just accomplished.
And hey, don't underestimate what you just did. In just a few minutes, you designed a database schema, you populated it with data, and then you wrote a pretty complex query to get a meaningful answer. That is the complete end-to-end workflow of a data professional. You just did it.
And you know, the best part is, this is just the beginning. I mean, what else could you add to this? A table for grades? For teachers? What about attendance? The foundation you've just built is endlessly expandable. And that is the real power, the real elegance of SQL. I really hope this little project has sparked your curiosity about what's possible with data. So now that you know how to build things, the next crucial concept is safety. Join us next time as we dive into transactions. We'll learn how databases make sure your information never gets corrupted, even when things go wrong. Until then, keep building.